What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at our fourth and final index law, and this is what happens if we have a negative power. So if I ask you intuitively, hey, what's 3 to the power of negative 2? A good guess would be negative 9. 3 to the power of 2 is 9, so throw a negative in there. Negative 9 makes sense. But this isn't actually correct, and we're going to prove it in a couple of different ways. The first way is through pattern recognition, and we're just going to see what happens as we get towards 0 and then go into our negatives. 3 to the power of 3 is equal to 27. 3 to the power of 2 is equal to 9. To get from 27 to 9, I have to divide by 3. And we're going to see this pattern continues to happen. Then 3 to the power of 1 is equal to 3. Divide by 3 again, and 3 to the power of 0 we know is equal to 1, so it's another divide by 3. It doesn't really make much sense 3 to the power of negative 1 to be negative 3. To get from 1 to negative 3, I would have to times by negative a third, and that doesn't fit the pattern at all. What does make more sense is that the pattern of dividing by 3 will continue. That means 1 divided by 3 is equal to 1 over 3. We know that pretty easily. And this is the answer for 3 to negative 1. Then 3 to the power of negative 2, I've got to divide by 3 again. So that becomes 1 over 9. This is a smaller fraction, a third as small as our 1/3. So this continues to make sense. Finally, 3 to the power of negative 3 divided by 3 is equal to 1 over 27. You might be able to see a pretty clear pattern emerging. These negative numbers have the exact same value, it's just on the bottom of a fraction. 3 to the power of 2 is 9, 3 to the power of negative 2 is 1 over 9. And we're going to see this in another example just now. Our second proof, we're going to use division. So if I have 2 to the power of 3 divided by 2 to the power of 5, I know that with my division rules, I can just subtract those numbers. This is equal to 2 to the power of negative 2. If I write this expanded out, I would have 2 times 2 times 2 on the top, divided by 2 multiplied by itself 5 times. Again, I can cancel out times 2's that are on the top and the bottom. So I cross the top 3 out and cross 3 out on the bottom. What I'm left with is 1 on the top over 2 times 2, or 2 squared. This means that this 2 to the power of negative 2 is equivalent or the same as 1 over 2 to the power of 2. So what we need to know is that a positive base will always give a positive answer, even if the indice is a negative. And that's really important. It's just getting closer towards 0, but it's never going to become a negative number. The best thing about this is that the maths is not hard at all. If I've got 5 to the power of negative 2, all that happens is I put that on the bottom of a fraction, 1 over 5 to the power of 2. The only difference between these two things is that negative becomes a 1 over. Again, with algebra, it doesn't really make a difference. X to the power of negative 3 just becomes 1 over x to the power of 3, full marks. You might also be asked to go the other way. I might have 1 over 4 to the power of 3, and the question might say, rewrite this as an indice with no fractions. This would just be equal to 4 to the power of negative 3. They're the same exact thing, it's just being replaced with a negative indice, but no fraction. So the only way this can get a little bit harder is if I've got a coefficient out the front. So if I've got 3 multiplied by x to the power of negative 2, I'm actually going to write this in extended form so I can see exactly what's going on. The 3 is just 3, and that x to the negative 2 becomes 1 over x squared. If I multiply a whole number by a fraction, it only multiplies the top number. So this becomes 3 over x squared, and that's my final answer. The thing that we need to take away from this is that the coefficient at the front just goes on the top of the fraction. So instead of doing 1 over, if there's a coefficient, we put that on top and still move our negative power to the bottom of a fraction. So for this one, I've got negative 6 y to the power of negative 2. And again, I'm going to extend this out. I've got negative 6 times y to the power of negative 2. But all I really need to know is that negative 6, the coefficient out the front, is going to go on top of the fraction. So this just becomes negative 6 over y to the power of 2. So these two are exactly the same. And a very common question will be, hey, write this indice with only positive numbers, and this would be the correct answer. So again, I could go the opposite way. If I've got 3 over p to the power of 7, and I get asked to write this in no fractions, all I've got to do is 3 p to the power of negative 7, and we're done. The last one we can see is powers on the top and the bottom, and for this one it might say rewrite this, but not in fraction form. all that happens is the top number remains the same, that's just still x to the power of 3, and the y value becomes a negative, so y to the power of negative 2, and we're done. For our final extension, we could have a negative power on the outside of some brackets. What happens here? We know that if we've got brackets, we multiply the powers together, and that's going to be our first step. So for this one, I've got x to the power of negative 6 over y to the power of negative 12. That's our first step. I know that if I've got a negative on top of a fraction, that has to come down to the bottom. So I'm going to move this x value to the bottom. And then the y to the power of negative 12 already on the bottom is kind of like having two negatives together. We know it's negative if it's at the bottom, but it's also a negative power. These two negatives are going to get rid of each other. So the y is going to go to the top of the fraction, but positively. So the answer for this question is y to the power of 12 over x to the power of 6, and this is full marks. So I know that this question is a lot of information, but it's a combination of a lot of the skills we've been learning. How do we multiply terms with brackets, and what happens if there is that negative on the top and the bottom of a fraction? Thanks so much for watching this lesson, guys, and I'll see you later.